Okay, so in the last couple of videos, we went ahead and set up brought some images in for the rendering, uh, graphics in, images for the 2D, models for the 3D, but all we've done is bring them in. We can't really move them yet. So before we call it a quick start, we probably want to at least be able to move our character around. So now let's go in and add at least the WASD simple movements around for the 2D and the 3D version, which will involve checking key presses, and that'll be a quick start. And then we can refer to that stuff: the loading in the image, setting up collision bounds, adjust, and then what we're going to do: adjusting the position and rendering it on the screen, all handled in an object. A game object that we can reuse over and over again for like our player, our players and the mobs and the NPCs and props and background stuff and everything we want in the game. We want an object that we can just quickly that will quickly do all that stuff for us, so we don't have to type it completely every time. And then once we have that object, we'll set up a method in the game writer to add the number of objects, to add objects as we need to interface with our engines. So I guess just to have the starting point in front of us as a reference when we go putting the objects together, I'd like to go ahead and make the characters move in both 2 and 3D. So let's do that real quick. Okay, so I guess we don't need this right now. And what I'm going to do to keep track of this X and Y, instead of just typing using magic numbers, just typing in random numbers, I'm going to set up some global variables. Again, this is just a test one, so we'll have some more precise values later. And I'll just start it at the same position, an X of 123 and a Y of 234. So that will be our X and Y. So that's what we'll pass into the character each time. Player X, player Y. And then to adjust those, we can just listen for a key event and adjust those global variables if a particular key event happens. So I already have the event listener set up. So this loop is going to go through every event that PyGame knows about and check to see which one we have. So if it's not a quit event, obviously the next thing to check is going to be, is it a type event? A typing event, sorry. I was typing the word type as I said that. If event.type is PyGame something with the keys, I'm going to go with key down. Obviously, key down and key up are going to be our main two. But I'll go ahead and go with the key press. So if the event is a key down, well, then we want to check and see what key it was. So if an event is a PyGame object, so we have lots of stuff in there. And that's the sort of thing that I'm scavenging from the game engines. There's a lot of simple there's some movements built in, but that's just some simple addition and subtraction for this case. It's going to be linear algebra when we get over to the 3D one. Over here, it's just simple addition and subtraction. So instead of trying to remember those built-in methods, I'm just going to do that simple addition and subtraction. So in our event object, one of the attributes we can check is what key is it that was pressed. So we can check a whole bunch of constants. So PyGame, and then all of our keys start with a capital K and an underscore. That's not an underscore. So K underscore and then the key we want. For the letters, they're all lowercase. So if the event is an A that was pressed, let's call this method player control that will move our character. And I'm going to come up here and write the player control method right underneath the player. And again here, once we get this test run together, we'll put this into an object. We want to make sure our logic works before we get to the more complicated syntax for classes and inheritance and all that. So I'll create this player control method. And what I'm thinking is just pass in a value for each key press. So a left, down, right, and up. And we'll just move in that direction. So left, down, right, oops, forgot a comma, right, and up. We'll set it up with 4 parameters, one for each of our directions. And then we'll be adjusting a global variable. And remember, in Python, we can access global variables, but if we want to change them, we have to throw in the keyword global and say we're actually using the player global, player X and player Y at the global scope, not the local scope. And I'm just going to pass in 1s or 0s for these, just to match a key press. If the key is pressed, it's a 1. If it's not pressed, it's a 0. So I'm going to add in a speed variable to make this easy to adjust. I'll guess 5 for a starting point and see if it needs changed from that. And then with each key press, well, we can just adjust our position variable by whatever direction times our speed. So we'll do the addition assignment. So X is going to be left and right. So we'll take our speed and multiply by left. And I'll duplicate that line. Or we might do our speed multiplied by our right. So I'll pass in like a -1 for a left, which when the A key is pressed, pass in a -1. And when the D key is pressed, pass in a +1. So that'll take care of the left or right. Just adjust our position by 5 pixels. And we'll see what 5 pixels look like and adjust the speed if we need to. Then kind of the same thing for the Y. So player Y, we have to adjust here. Because when I'm thinking about this, up, or the W key is going to be up. But remember on a screen, if it's not changed, and PyGame did not change it, the positive Y is down. Sort of like going down a page, like the line numbers on a page. The positive line number goes down. So our Y value on a screen is the same way. So I'll adjust that here and do subtraction assignment to at, and that way I can just pass in a +1 for up and a -1 for down. That just makes more sense in my mind. But we do probably want to make that adjustment somewhere in there. So times the down player Y minus subtraction assignment for speed times up. So that'll control our movements. And then we just need to pass in those values. So if the A key gets pressed, well, that's what we think of as left, which on our XY axis, left is usually the negative direction. So if it's an A key that's pressed, we'll pass in a -1 for left and a 0 for everything else. And then we'll just do that for each one of our keys. So I'm going to copy that. Whoops. Go back, paste that, and I'm going to change this to 0 to copy this again. And then copy in all the zeros. So A, S, W, D. And now change those keys. S, D, W, and S, that's going to be down. So down is typically what we think of as -1 on an XY axis. The D key is to the right, and to the right on our normal math class XY axis is a positive. So I'll pass in a +1 and a +1 for the W. So there's one other thing we'll need to change, but I want to see it first, so it'll make sense why we're changing it. And then we'll just basically pass in these values and change this global XY position, or the XY position of the object when we get to that here in just a couple of videos. So I'm going to go ahead and run this. Expected an indented block. Oh, that should be indented. That should be non-indented. There we go. So if I push D, it moves over. But I'm holding D right now. It only moves over the one click. A, S, W. So this is the other thing. We can tap it and keep moving. But this comes from the operating system. When we push a key, unless the software tells the operating system otherwise, that key press only adds one press event to a queue. So we need to add more of those. So we need to set that up, and that's part of our initialization. So we'll come up here. Well, I usually do it in the initialization like this. We will likely include this in our object. But we need to tell the operating system we want to be able to hold the key and do the thing repeatedly. So we can, in PyGame.key, we can call this method set repeat. And then we need two numbers passed in, a delay and an interval, both in milliseconds. So I've done like 10. It's how many milliseconds between that repeat. So our game engine is running at 60 frames per second, which is 16 point repeating sixes, so 16 or 17 milliseconds every frame. So we could match that. I'll go with 17, or 16. But over the years, so you can match that exactly. Over the years, I've found I like to double that repeat on the key press. And I have trouble explaining a good reason why. So I'm going to go with double what the speed is. So instead of 16 milliseconds between them, I'm going to double that and go with 32. So it's going to check that another key press every other frame. I guess I might as well do it every frame. I'm just getting started here. It's definitely something to adjust. So I'll do every 16 milliseconds. And part of that is it's not going to come out evenly with 16 frames per second if we're typing in milliseconds, because these do have to be integers. So now if we go run this again, holding down the key, it continually moves across there. So he covers the screen awful quick. The size of that character, I'm going to decrease the speed a little. So maybe try 3, just because it's kind of a big screen for the size of the character. That'll work. Gets us around, but that's the simple move. That's the simple WASD movement. So we want to make sure and tell the operating system it's okay to repeat keys when they're held down with a delay and interval. And I always just feed in the same number for those. I've never done a lot of experimenting with changing that. They're both milliseconds. So just feed in how many milliseconds between. And then just calling this method and passing in either a -1 or a 1 when our event type happens to be a key and we figure out which key it is. Then we just adjust some global variables that actually define the position of our character. So that gets us, that's more of a quick start on this. We loaded in our images and we can move them. So that's the quick start. So let's go finish out the quick start on the 3D model. And then we'll come back and clean all this up for a proper class to create objects from.